So this is the underlying assumption in this chapter and in the previous chapter that we talked about, is that consciousness, which is our experience of the world around us, ultimately, it is the result of brain activity. So that what you experience, what you feel, what you do, is all ultimately the result of these billions of neurons in your nervous system talking to each other. And when we talk about consciousness, we're just talking about your experience of the world. So we went into that system in depth in chapter 2. And one concept that I didn't make explicitly clear in chapter 2 that I want to make explicitly clear now is that there is no one place in the brain where it all comes together. There used to be this idea that there was this little person, this little man or this little woman in the center of your brain, kind of like a semi-truck driver, sitting at the wheel and at the control, changing the gears, pressing the buttons on the screen. Like there's this little tiny dude or woman, in the middle of your brain, sitting in this control room, surrounded by screens, and constantly pressing buttons and, oh, let's send this here and send that there. And there's this little person in charge in the middle of your brain, right? Where it all comes together, where kind of your soul lives, right? That's kind of what Descartes thought, remember? Descartes thought that your soul lived in your pineal gland, which actually we'll come back to here in a second. We'll talk about the pineal gland a little bit more momentarily. But Descartes thought that the soul lived inside the pineal gland, right? And other folks have hypothesized in more recent years that maybe it's the thalamus, right? Because that's the sensory relay station where most of your senses seem to come together. But even there, not even all the senses go through the thalamus. Even smell has a different route, right? And what you find when you look at the mind and when you look at consciousness is that there's not one place in the brain where it all comes together. There's not. In fact, what you find are lots of, if not dozens, if not hundreds of separate processes that are happening throughout the brain, if not thousands, really, you can break them down ad infinitum. But what you see when you look at the mind is just a set of processes that are happening throughout the brain, which we experience as being a unified experience, a gestalt, like the gestalt psychologists talk about. We experience it all as being one thing, but in reality, there's nowhere in the brain where it all comes together. And these are all separate processes. And the experience that we have from moment to moment of all of this being one unified consciousness is actually an illusion, believe it or not. And in fact, one thing that we'll see in this chapter, and I'm not sure how far we'll make it through this chapter today, hopefully we get through most of it, is that various experiences can actually alter your experience of consciousness so that this experience of unity can actually be broken down. For example, in states of intense meditation or psychedelic drug use or flow states, or intense religious experiences. The feeling of self can dissolve and you have this experience of oneness with the universe, right? Or you start to experience your senses separately, and the separation between them, the fact that they're separate processes start to become apparent, right? And you can have these vivid sensory experiences in meditation and through psychedelics. And by the way, I'm not encouraging illegal drug use. So don't go home and tell your mom, oh, my psychology professor is going and telling me to try mushrooms. I didn't say that. I said no such thing, right? I would never encourage anyone to break the law. But in any case, you can have these intense experiences brought on through different means where we can experience the world in very different ways. And it can become very apparent during some of these unusual experiences, which I've had some of them myself, primarily through meditation, that you experience the illusory nature of the self, and you experience that this feeling of unity between all your different senses is actually an illusion. They're actually all separate consciousnesses all happening at once, right? But these aren't typical experiences. On a moment-to-moment basis, we experience them as all unified, right? But the global workspace model is just simply a model that gets at this idea that there is no one place in the brain where it all comes together. Another fact about the brain that says a lot about consciousness that's interesting to know about is the fact that the two hemispheres of the brain are divided into separate hemispheres. I touched on this fact, and it looks like I left my water in the kitchen and I'm getting dry mouth. I might have to excuse myself here for a second to go grab my water. But I touched on this briefly in chapter 2, but it turns out that the left and right sides of the cerebral cortex have very different personalities. Now, for one thing, the left side of your cortex controls the right side of your body, and the right side of your cortex controls the left side of your body. I mentioned this in chapter 2 already, but I just wanted to remind you guys of this fact. This is what's known as contralateral control, that, the brain's crisscrossed, right? They control opposite sides of the body. And this is true for most people, by the way. There's some evidence that there might be a handful of people on the planet who actually don't have contralateral control, and the right side controls the right side and the left side controls the left side. It's incredibly rare, and it's typically associated with people who are left-handed, by the way, although this is not true of all people who are left-handed. But there is some evidence that folks who are left-handed might be different in this regard in some ways, although I'm not an expert on this topic. So if you were to pepper me with questions, the specifics on this, my answers would probably be, I don't know. But there's some evidence that left-handers are different in this regard sometimes, but not all left-handers. So it's a complicated literature. But for 95% of humans, roughly 95% of humans, there's contralateral control, meaning the left side of your brain controls the right side of your body, and the right side of your brain controls the left side of your body, which is interesting that evolution selected for that. You find some weird things like that in our, but another thing that you find when you study the split brain pertains to individuals who have had a procedure known as the split brain procedure. Is anybody familiar with this procedure? Has anybody read about it? What do you know about it, Brandy?
I don't know a whole lot about it. Basically you go on pretty much normal, but it is to stop seizures and, really bad cases anyways, and in certain circumstances.
Yeah, so that's basically it. In a nutshell, there are individuals who have such severe epilepsy, and it's not just epilepsy, there are other seizure disorders other than epilepsy, but epilepsy is by far the most common seizure disorder. My dad had epilepsy that was so crazy once that he had a grand mal seizure where he nearly knocked out his grandmother, who was my great grandmother. But he would have these. I remember one time it was just absolutely frightening. He just about destroyed his living room. My dad had really serious seizures, and he's no longer with us. Anyway, that's not what took him out, but his seizures were usually controlled by medication. As bad as my dad's seizures were, and thankfully, I don't seem to have inherited his epilepsy, knock on wood. I've made it to 36 years old and I haven't had a seizure yet. So I think I'm probably in the clear, but sometimes people do develop them later in life. But my dad was having his seizures by the time he was a teenage boy, right? So I think I didn't inherit that, and I got lucky. But in any case, my dad's seizures were so terrible that they were, I mean, he practically wrecked his house once before the paramedics arrived, and were able to sedate him sufficiently. He was hospitalized for days after that seizure. But in any case, most folks, even like my dad, even with really bad epilepsy, most folks with epilepsy are able to control it through medication in the vast majority of cases. Now, anti-seizure medication, they're called anticonvulsants, actually. Anticonvulsants can have some nasty side effects. But for most people, their seizures are so bad that the benefits of the medication outweigh the nastiness of the side effects, right? They'd rather deal with some drowsiness and shaky hands, as a side effect from the medication than having seizures all the time, right? So it's like you weigh the pros and cons, right? And you decide what's worse. But in any case, there are some folks who have epilepsy that's so severe that it can't even be controlled by medication. So the last resort surgical intervention for this is to either partially or fully, and it depends on the case whether it will be partially or fully, but to partially or fully sever the connection between the left and right sides of the cerebral cortex. The connection that connects the two sides of the cortex is called the corpus callosum. And it's a bundle of about 1 million axons. So it's a nerve fiber, basically. Remember, I said in chapter 2, a bundle of axons is called what? A nerve, right? So when you hear the term nerve, that's just a term for a bundle of axons, right? So the optic nerve, for example, is about 1 million axons that exits each eye. The corpus callosum is a nerve fiber of about 1 million to 2 million. It's a little thicker than the optic nerve. Actually, it's about at least double the size of the optic nerve. But it's a significantly sized nerve fiber of about 1 to 2 million axons that connects the two sides of the cerebral cortex. So in most of us, the two sides of our cortices are connected and they talk to each other. But for these folks, they've had this bundle of axons severed. And you would think that this would have significant, severe, noticeable side effects in everyday life. The surprising thing is that when you talk to a person with a severed corpus callosum, they don't really seem any different than you or I. They might seem maybe slightly slower sometimes, because you can forgive them for that, right? Because they've had a portion of their brain cut in half, right? Now, keep in mind, it's not the entire brain, right? If you had your entire brain cut in half, you would die. So we're talking about, just this portion of the brain, we're not talking about cutting the entire brain in half here. Don't make that mistake. I've heard students say that. We're not talking about cutting the brain in half. We're talking about cutting the corpus callosum. But in any case, when you talk to somebody with a split brain, and I've never talked to someone with a split brain, but I've seen interviews, videos, right? They might just seem like, maybe someone that's just a little bit slower cognitively, right? Maybe not quite intellectually disabled, but they might seem like someone whose brain works a little bit more slowly, but not a big deal sort of thing. On the surface, it's not too noticeable. But if you put them into a laboratory environment and you run certain tests on them, and there's a great video on this, which I don't have time to play because I'm trying to not get behind again, which I probably will anyway. But there's a great video. There's a couple of videos on this on YouTube. And if you guys shoot me an email and remind me after class, I can email the link out so you guys can check it out on your own time, because it really illustrates this really well. But if you put these patients into a laboratory setting, you can really see, you do certain tricks and you can really see the effect of the severed corpus callosum on their cognitive processing. It has some really significant cognitive effects, but you really have to put the person into a laboratory environment to and know what you're doing. You basically have to be a neurologist or a neuroscientist that knows what they're doing, or at least have some training to really demonstrate these effects. A layperson really isn't going to probably be very effective in drawing these things out of these patients, is what I'm trying to say. But if you have a trained eye, you can really see it. But what this research has really shown us is that when you put these people into a laboratory setting, the left and right sides of the cerebral cortex, it turns out they have different personalities. So have you ever heard someone say, oh, Mr. Carr is really left-brained, or Mrs. Carr is really right-brained, right? Or, I'm not saying you've heard people talk about my wife or I, but, in general, like if you've ever heard someone referred to as left-brained or right-brained, has anybody ever heard that terminology before? That's from this line of research, right? So if you say that someone's really a left-brain sort of person, basically you're saying that they have more of an analytical, intellectual sort of way of seeing the world. The left side of the brain is seen as sort of like the intellect, right? And there's some truth to this, by the way. If you look at the split brain research, you can see why, even though it's a little bit of an overgeneralization, there's some truth to it. So those who are left-brained are who are, the analytical engineering types, right? And those who are right-brained are more of like your artist, your touchy-feely sorts of folks, right? Who are, into expressing themselves artistically. They're more interested in expressions of emotion. They're more emotionally inclined sorts of people. So, you a little bit of an oversimplification, but you might see it's sort of like the head and the heart, right? Kind of thing. So someone who is very left-brained, it has sort of a more analytical, intellectual way of approaching the world. And someone who is right-brained is going to have a higher likelihood of maybe being an artist or a musician, or someone who is more empathic, that sort of personality. And of course, these are oversimplifications, right? In reality, all of us use both sides, right? So all of us have a left brain and all of us have a right brain. It's not the question of whether or not you have it. It's a question of, which side of your brain dominates you more is what we're getting at here, right? So again, it's a little bit of an oversimplification, but there's some truth to it, right? Any thoughts, comments on the left brain versus right brain thing before we move on to talking about circadian rhythms? Any other thoughts? I'm going to go grab my water here before I start coughing at you guys. I'll be right back. Yes, this is one of those Bamboo Willys cups, and it turns blue when you put cold water in it. So, no, I promise it's not an adult beverage. It's too early for that. Although, don't tempt me, JK. All right, so I think that's enough on the split brain stuff if we don't have any further thoughts or questions on that. Okay, so one of the biggest topics in this chapter on consciousness, and it makes sense because we're talking about states of consciousness at this point for the rest of the chapter, is the stuff on circadian rhythms, aka sleep. Now, circadian rhythms is actually a catch-all term for any sort of biological cycle which is influenced by the passage of time, or particularly sleep-wake cycles in particular. So your biological cycles, which are influenced by, the passage of night and day, we refer to those broadly as circadian rhythms. Now, mainly when we talk about that with humans, we're talking about the sleep cycle, right? So when we talk about circadian rhythms, mainly we're talking about sleep for the purposes of this chapter. So sleeping is an interesting neurochemical process in the brain. Interestingly enough, even though we understand a lot of the neurophysiology behind sleep, we don't actually completely understand why we sleep, believe it or not. Our scientific understanding of sleep is actually in its infancy. We've only been studying sleep for a little over half a century. It wasn't really until the 1950s until we actually started to identify the different stages of sleep and started to use EEG to study it. And with all that knowledge, we still don't know exactly what sleep does, what its purpose is. We do know that we'll die if we go without it. We do know what the limits of human sleep deprivation are. By the way, the Russian sleep experiment is that's an urban legend. If you ever come across that on YouTube, total bullshit. None of that, I'm pretty sure none of that ever happened, but prove me wrong. But yeah, I could be proved wrong, but to my knowledge, the study which has demonstrated the human limits of sleep was done in the 1960s in the United States by a healthy teenage boy who volunteered. And if I remember correctly, actually, I forgot the amount. What was the longest amount of time without sleep?
I found this on the web.
Randy Gardner, that's his name. He's still alive. He's 73 years old now. He set the record in 1964. When he was 17 years old, he stayed awake for 11 days and 25 minutes. So 11 days and 25 minutes is the documented, still to this day, no one's broken it that I know of, the world record. So he went 11 days and 25 minutes. And you can read all about it. There's all sorts of stuff about it online. But, he didn't die. He just was not able to stay awake any longer. His body would not let him. He could not stay awake any longer, despite all his efforts. Yeah, Soul.
Did he use
Oh, I'm sorry, I didn't mean to mute you. I think I muted you by accident. There you go.
Did he use caffeine or no?
I believe no. Yeah.
Oh.
But I might be mistaken about that. I'd have to read further. But yes, I believe that was that is a stimulant-free world record. So there may be another higher record for folks who have used amphetamines, and caffeine. I mean, Adderall is a hell of a drug, and I wouldn't be surprised if there are folks who have been able to shatter that record using amphetamines. But the non-caffeinated, non-stimulant, the stimulant-free world record is Randy Gardner's 11 days and 25 minutes. Yeah. I don't know what the record is with stimulants. It's probably much higher than that, I would assume. Yeah. Okay, so I do know that if you get to a certain point, though, in animal studies, for example, there have been rat studies, rodent studies, and I think rabbits too, where they've kept rodents alive with caffeine and not allowed them to sleep, right? And eventually, if you do this to non-human animals, they eventually will die. So, I don't know what the limit is for a human being, where human beings will start to die. There's an urban legend about a Russian study, like I mentioned, where the Russians actually found out, how much sleep deprivation it actually takes to kill someone, and the people went insane and started eating themselves and tearing their own eyes out and eating their own flesh before they died. My understanding is that that story is an urban legend, but again, prove me wrong. I've been wrong before. So, but I don't know. But we do know from some rodent studies that that you get to a certain point and an animal can die from sleep deprivation, right? So we know we can die without it, but we don't exactly know what it does for us other than keep us from dying, right? It seems to be a basic biological need, like eating and shelter, right? You will get to a point where enough deprivation of sleep will kill you. But the key hormone, and there are lots of neurotransmitters in the brain involved in sleep, by the way, like adenosine, I talked about already in chapter 2. I talked about GABA, which is another one. So melatonin is one of many chemicals in the brain involved in the process of sleep. And we might argue that melatonin is perhaps one of the more important ones, but they're all important. But melatonin arguably is the neurotransmitter that plays the key role in getting that chemical cascade started, right? So there is a gland called the pineal gland. It's a little tiny gland deep within your brain, near your hypothalamus. It's about the size and shape of a chickpea, by the way, interestingly enough, which is what they make hummus out of. Now you'll never be able to eat hummus. You're going to think you're eating brains, right? But yeah, the pineal gland is a little gland about the size of a chickpea deep within your brain. And its job is to produce the hormone melatonin. Interestingly enough, like I've mentioned before, Descartes thought that this is where your soul lived, in your brain. Now, whether or not the soul lives here, that's a metaphysical question. I can't answer that. But what we do know is that the pineal gland is critically important for the regulation of sleep. It produces melatonin. And when it starts to get dark out, there is another structure located on the hypothalamus called the suprachiasmatic nucleus. And when it starts to get dark out, the suprachiasmatic nucleus sends a signal to the pineal gland, telling it to release melatonin, which it produces as well, right? So when it starts to get dark out, the suprachiasmatic nucleus, which is located on the thalamus, actually the hypothalamus, I'm sorry, I misspoke. The suprachiasmatic nucleus, located on the hypothalamus, sends a signal to the pineal gland saying, release melatonin. This causes a flood of the hormone melatonin to start to be released throughout the brain. And this flood of melatonin causes the other neurotransmitters that we've talked about, like GABA, like adenosine, and others, which we haven't talked about, to start to be released as well. So once the melatonin starts to flow, these other neurotransmitters involved in sleep start to flow too as a result of this. It's like a cascade of chemical reactions in the brain. And that's triggered by it getting dark out, right? Interestingly enough, melatonin is one of the few hormones that you can buy over the counter in the United States. In fact, I believe there are 2 hormones that you can buy over the counter in the United States. One of them is melatonin, and the other is DHEA, which is a hormonal precursor to testosterone and estrogen, by the way. So some bodybuilders take DHEA thinking that they're going to increase their testosterone levels. And they will, by the way, and I'm getting off topic here. But just know that if you take the hormone DHEA, which is totally available over the counter, you are consuming a substance that is considered a banned substance by most athletic agencies. So even though it's legal to buy, it's considered a banned substance. It's considered a mild steroid, basically. But a lot of bodybuilders take it to up their testosterone levels. But another side effect of taking it is it also increases your estrogen levels too, right? So it's increasing both. So you're buyer beware, right? But melatonin is the other hormone that you can buy over the counter. And a lot of people use it to treat insomnia and jet lag. Interestingly, melatonin is really the sort of supplement that you have to take for a while before it starts to help. I've had a lot of students say, oh, well, I tried melatonin for my insomnia and it didn't do shit, right? Well, what usually happens is you're not taking it long enough, right? You have to take melatonin at the same time every night for about a week before it starts to work. Interestingly, now don't ask me why that is, but that seems to be the case. I'm not a neurologist, and there's probably nor am I a neuroscientist, but there's probably some neurochemical reason why that's the case. Kind of similar to antidepressants. You have to take them for about a week or two before they start to work. Even though they start to increase your serotonin levels in your brain immediately, as soon as you start taking them. You don't feel the mood elevating effects of antidepressants for about a week or two after you start taking them, which is a strange thing that's always been noted about them.
Maybe our bodies are good at leveling out unusual spikes.
It probably has something to do with that. Yeah. Something having to do with the metabolism of these substances in your brain, right? But honestly, we don't completely understand that yet as a science. And, one of the frontiers of antidepressant research is developing antidepressants that work immediately, right? And we don't have that yet. One promising drug actually is ketamine, actually, believe it or not, which prior to its discovery as an antidepressant, it was used as a date rape drug. So go figure, right? So it's amazing how a drug can be used for good or evil, right? The same drug can be either used to overdose someone and make them unconscious so that they become a victim, or a much smaller dose taken before bed each day could possibly cure someone of their depression. So that's why, when it comes to drugs, which is another topic in this chapter, by the way, I try to avoid demonizing mind-altering drugs. Like the Nancy Reagan approach of the 1980s, and I'm showing my age a little bit here. Most of you guys won't remember this. But when I was a kid growing up, there was the Just Say No campaign. And there was this stupid program called DARE, where police officers would actually come into classrooms with real drugs, by the way. I learned what weed smelled like from a cop, from a DARE lecture, believe it or not, right? These cops would actually come into classrooms and bring drugs into like middle school and high school. So it was like, hey, this is some cocaine, right? And this is some weed. And they call it blow on the streets. And you don't try this, it's real bad. It'll mess you up, kids. Big surprise. They did research later on, like 10 years later, they found out that kids who were part of DARE, and yes, I was a kid that was part of DARE growing up. I was a victim of that program. Kids who went through the DARE program were much more likely to try drugs than kids who didn't. So it actually had the exact opposite effect of what they were intending. But I think the reason why it had that effect was it was like this sort of forbidden fruit thing, right? It's like, don't do this. This is bad, okay, right? It reminds me of that South Park episode where, they go to this anti-cigarette smoking assembly, right? It was like this don't smoke, some of you guys are chuckling, you've seen the episode, right? It's an older episode of South Park. But like, it's this totally asinine routine, right? And by the end of the episode, all of the kids, you know, Kenny, Cartman, Kyle, Stan, they're all out back behind the school trying cigarettes after it, right? Because, you know, like they've just made it look really forbidden and cool, right? So I think that's what's behind that. And I think when you turn drugs into a forbidden fruit, it makes them much more appealing. But with that said, I lost my father to the opioid epidemic, right? It killed my dad. Opioids killed my dad. An accidental opioid overdose took him from me when I was 15 years old. So even though I'm, you know, kind of libertarian when it comes to, you know, I think most drugs should be legalized and, you know, it should be seen as a medical issue, not necessarily a moral issue. With that said, I know it's a serious issue because, you know, I lost my father to drug addiction. So again, I'm getting ahead of myself here. I wasn't ready to start talking about drugs yet towards the end of the chapter. But what else do I want to say about sleep? I want to say a little bit about dreams. I'm not going to make you guys be familiar with memorizing the different stages of sleep. The exams are open book, so if you do happen to get any random questions out of the question banks on the exam that ask you to identify what stage of sleep it is based upon, you know, the type of wave form, all of that information is in the textbook, and the exams are open book, so I don't think you would have much trouble finding that information pretty quickly. So I'm not going to make you guys memorize it, but just know that different stages of sleep are identifiable as different waveforms on an EEG. And the most well-known stage of sleep is rapid eye movement sleep. Most of our crazy dreams happen during rapid eye movement sleep. Oh, we've got company. Our goddaughter has just arrived. So if there's noise, you'll know what it is. But we've only got about 15 minutes left anyway. But in any case, you know, we spend about 6 years of our lives in REM sleep dreaming. And REM sleep dreams tend to be really memorable and bizarre, right? During rapid eye movement sleep. Those dreams that you tend to remember as, wow, that was a weird dream. What did that mean? Right? That was probably a REM sleep dream. And interestingly, during REM sleep, the brain is extremely active. So your eyes are moving around rapidly behind your eyelids, and your brain waves look just like they do when you're awake. In fact, the brainwave activities of a person who's dreaming are just about identical to a person who's wide awake. The brain is incredibly active during REM sleep. So most of our crazy wild dreams happen during REM sleep. Now, we do have more boring dreams sometimes, and those dreams tend to happen during deep sleep, where the brain is much less active. It's what we call delta wave sleep, in case you're wondering the waveform type. But those are long, slow brain waves on an EEG. So delta wave sleep or deep wave sleep is typically characterized by more boring, sort of non-memorable dreams. Like, so for example, the other night I had a dream that I was walking through the hallway of my house during the middle of the day where I live, which, since I work a lot from home, happens to me all the time, right? So I had a dream about me doing something that I do all the time. And there was not anything special. You know, there was no wormhole to another dimension in the middle of my hallway. There were no monsters. It was literally the same experience as if I were to walk outside that door right now and walk through the hallway. It would have been the same experience that I had during my dream, right? Minus the barking dog and the 3-year-old. That's a non-REM sleep dream. There's absolutely nothing interesting or memorable or meaningful emotionally about that. That's how non-REM deep sleep dreams tend to be. But those crazy memorable dreams tend to happen when our brain is really active during REM sleep. And thankfully, for most people, our bodies get paralyzed during REM sleep so that we don't act our dreams out. But what do our dreams mean, right? there are basically two broad lines of thinking on dreaming in psychology. There are folks who tend to believe that dreams have deep psychological meaning. And there are folks who tend to believe that they're basically just random brain activity in your brain while you're asleep. It's just basically mental garbage of your sleeping brain, basically. It's just mental nonsense, more or less, right? And it's meaningless. So folks who believe that dreams are deeply meaningful, I, by the way, just in case you're wondering where I side, I tend to lean more towards the dreams are meaningful side. And I'm a minority, by the way. Most psychologists have gotten away from this type of thinking in recent years. So I'm kind of atypical in this, and a lot of the experts disagree with me on this, and you're welcome to disagree with me too, by the way. Both points of view are represented in the textbook, and in fact, even the textbook's slightly critical of my point of view on this, and that's okay. I'm not threatened by that, and I'm always open to people changing my mind on my points of view on different topics. But based upon my experience working with people, working with students, working with people clinically, and the little bit of clinical experience that I've had in the past, I look at it this way. We spend 6 years of our lives dreaming. That's a lot of glucose. That's a lot of mental energy. That's a lot of resources. I don't think our brains would evolve to do something that was a total waste of time and meaningless and do so damn much of it. Maybe it's possible, but to me, it would seem really inefficient. Why do we do it so much if it's meaningless, for one thing? I know it's not the strongest argument, but that's one point that I have. Why do we do it so damn much if it's meaningless, right? It's got to have some, I'm a big fan of evolutionary psychology, right? And anything that we do a lot of, that our brains are good at, to me, must serve some sort of adaptive purpose from an evolutionary standpoint.
There's a lot of questions about it, because why do some people remember their dreams and others don't? Why can some people dream lucidly and control their actions in their dreams and other people can't? Why do certain drugs affect your dreams? Like, I'm on SSRIs and they give me crazy dreams. Nicorette gives people super crazy dreams.
Right.
Why?
And I know folks who smoke a lot of pot who hardly ever dream at all, right? And that's one side effect, by the way. If you have a medical cannabis prescription, and I'm not promoting that, by the way, because there are actually some really serious side effects that can result from smoking a lot of weed all the time. There's a condition that's actually becoming more well-known called cannabis hyperemesis syndrome, where folks who smoke a hell of a lot of weed all the time are actually developing this condition where they throw up constantly, which is ironic considering that weed's often used as a nausea treatment. But it's a real condition, by the way. You can look it up. I mean, 3 people have actually died from it. It's relatively rare, but it exists, and it can also cause short-term memory problems, and it can make you more susceptible to schizophrenia. So I'm not one of these people that's saying, "Oh, weed's bad. You should never smoke weed." Like, I'm realistic. I know people are going to smoke weed, but there are side effects of doing it all the damn time, right? And one of those side effects is never dreaming, by the way, which I've heard a lot of students tell me this, who've had their cannabis cards for a while. But in any case, yeah, so, some people can lucid dream, which means you can control your dreams. Some people don't dream much at all. And what you dream seems to be affected by what you eat for dinner, right? So I'm not denying that there's a certain randomness to it. And I do think some dreams are just mental garbage. But I think some other dreams are emotionally significant. And I'm only speaking for myself here, by the way. So if you don't connect with this and you think, you know what, Mr. Carr, my dreams don't mean anything, this is all hogwash, fine. It doesn't bother me if you come to that conclusion. I'm not threatened by that. You don't have to agree with me, but just based upon my own experiences, I've had some very deep, emotionally meaningful dreams that I have been able to devise some deep spiritual even truths from, I might even say. Um, I am kind of a fan of Freud's view of dreams. Now, actually, let me clarify that. Let me qualify that. I'm actually more a fan of his student Carl Jung. Uh, Freud believed that basically dreams were an expression either of our deepest fantasies or our deepest fears, right? So he said dreams contain two types of content: manifest content and latent content. And what you see on the surface of the dream is the manifest content, but the deeper meaning behind it is the latent content, right? And Freud basically believed that there are two types of ultimate meanings for dreams. And this is the basic message of his book, The Interpretation of Dreams, which I have on my bookshelf right over there, which I've read parts of. Brilliant, brilliant work. Freud wrote the book after his father died, which I can relate to, actually. The death of my father was a huge emotional event for me when I was 15. And when his father died, he was a grown man when his dad died, but it really threw him into an emotional tailspin, and he had all these dreams about it, and he analyzed himself, and his book, The Interpretation of Dreams, his most popular book, was the result of that experience. And to oversimplify a little bit, Freud basically said that ultimately the latent content of a dream ultimately comes down to your deepest fears or your deepest fantasies. That ultimately, whatever it is that you dream about is an expression of your deepest fears or your deepest fantasies. And ultimately, for Freud, most of the time that would boil down to either the fear of death or the desire for sex. So ultimately, dreams boiled down to fear of death or the desire for sexual union with another person, right? Carl Jung was a student of Freud's, and Jung thought that Freud's views on dreams were overly simplistic. And I agree with Jung on that, by the way. I think to boil everything down to fear of death or sex is overly simplistic. Now, I think some dreams boil down to fear of death and the desire for physical intimacy, but I don't think all dreams are boil down to that. Carl Jung was a student of Freud's, and he believed that dreams went even deeper than that, and in ways that I don't have time to get into in this lecture. But I'm a big fan of Carl Jung's ideas on dreaming, which basically come out of Freudian theory, more or less. But Freud was a believer that dreams had emotional meaning, and I tend to err on that side as well. Now, modern neuroscientists, on the other hand, have become much more fond of what's called the activation synthesis theory, which is basically a catch-all term for a family of theories that basically, like I said, puts forth the idea that that dreams are basically just random. It's just random brain activity while you're sleeping, and the experience that you have is basically just mental garbage that your brain is processing while you're sleeping, and that it doesn't really have any much deeper meaning than that. Which theory is true, I think really is the wrong question. To me, I think some dreams are explained by activation synthesis, and some dreams are, have more of a deep emotional significance to them. For example, I've had a recurring dream. I've had a recurring dream that's happened over the years. My father passed away when I was 15, like I mentioned. My dad and I loved to play chess together when I was a kid. It was our favorite bonding activity. Once in a blue moon, even now at the age of 36, even though in a year I'm going to outlive my dad. He was 37 when he died, and I'm 36 now. But, even though it's been so long since he's been alive, once in a blue moon, about once or twice a year, I'll have a dream where I'm playing chess with my dad, and I'll ask him for advice on various, whatever it is that I'm going through at that, and it'll be very vivid. And my dad will give me his advice. You know, of course, his advice is really just my advice, right? Because it's coming from within me. But my dad will give me my advice through his mouth, right? In my dream, right? He'll tell me what I already know that I'm not wanting to admit, basically, right? But about once or twice a year, I'll have this dream where I'll ask my dad, and I'll be sitting there playing chess, and he always wins in the dream, by the way. Whereas in real life, it was like a 50-50 chance. We were a perfect match for each other. You never know who was going to win. But in the dream, my dad always wins. And he gives me the perfect advice, right? But I'll have this dream where I'm getting advice from my father, and it's usually really good advice, right? I think that that's emotionally meaningful, and I think Freud would have a lot to say about that, and I think Carl Jung would too. And to say that that dream is just random nonsense of neurons firing in my brain, to me that doesn't fit, right? But
I have a question.
if I have a dream that I'm a banana, right, that's probably more random. Yeah, Carla?
How long after your dad died did you start having the dreams? Do you remember?
It was within months. Yeah.
That's cool. My dad died 3 years ago, and he hasn't visited me in any of my dreams yet. But some people that I know, they have them all the time. And some people that I know never have them. And so it's weird how that happens.
Yeah, and of course, some folks who are spiritualists might believe that the spirit of that person is actually visiting them through that dream. And I'm okay with that if you believe that. I mean, I don't have any scientific evidence to try to dissuade you otherwise. That's a question of faith, right? So, to me, science can't answer that question, yay or nay. Whether or not the spirit of that dead loved one is actually visiting you, or whether or not the spirit of that dead loved one is actually a projection of your own mind, I'll leave for you to decide, right?
I like the idea of the cardinals being somebody that's visiting you, because I really only see cardinals if I'm like in my tree stand or something. So it's really cool that was something that we did together. And so he's still kind of there.
Yeah. I can respect that. So again, how meaningful are dreams? I think the final answer to that question is up for you to decide. If you have a dream and it really means something to you, then you have the answer to your question. If it doesn't mean a lot to you, you have the answer to your question, right? But again, we really don't know why we sleep. We have some theories. We have some well-informed theories. The three most influential theories that you hear about in the textbook are the restorative theory, the circadian rhythm theory, and the consolidation theory. And these aren't mutually exclusive, by the way. These each might explain some of the reason. It might turn out that we don't sleep just for one reason, right? We might sleep for multiple biological reasons, and all of these might be part of that set of answers, right? And that's one thing that we find often in psychology. When we ask the question, why do we do what we do? Often it's not just for one reason, it's because of a set of reasons. Why we sleep ultimately is most likely going to be due to a set of reasons. But some of those reasons that have been proposed that seem plausible, one is the restorative theory, which is just the idea that it's a time for your body to repair itself while you're sleeping. And there's evidence for this, right? So one line of evidence for this is that there's a direct correlation between the functioning of your immune system and how much sleep you're getting, right? And the crappier your sleep, the more likely you are to get sick, to catch a bug, right? And also physical activity affects your immune system too, by the way. So being physically active is really good for your immune system, FYI. But being sleep deprived is really bad for your immune system. And there's a lot of evidence that experimental studies that have shown depriving animals, human and non-human, of sleep make them much more likely to catch a bug. We know this, right? We also know in studies that have been done of bodybuilders. If you look at bodybuilders who train for hypertrophy, does anybody know what hypertrophy is? Muscle tears, right? The way you build more muscle as a bodybuilder, which I'm not, by the way, I'm obviously not ripped, but I do a lot of running, which is probably the reason I'm not ripped, actually, because if you do a lot of running, it can actually impede, cardio fitness can actually impede building muscle mass. A lot of people don't know that. But in any case, back to my point, we know that if you're sleep deprived, it negatively affects your immune system. We also know that bodybuilders who train for hypertrophy, meaning muscle tears, you're basically intentionally tearing your muscles to make them grow back stronger, basically, right? That's how bodybuilders build muscle. That if you've engaged in that sort of hard workout where your muscles are, sore for days afterwards, that's called hypertrophy. Being sleep deprived after that kind of workout slows down your progress, right? And you hear this all the time. Bodybuilders will talk about how being sleep deprived slows their gains, is the term that they use. It's going to slow my gains, right? Bruh, it's going to slow my gains, bruh, right? But it's true. Being sleep deprived will slow your gains. You can lift all the weights you want, but if you're not getting any sleep, all that weightlifting will do is just tire you out and weaken your immune system. But if you're doing all that exercising and getting good sleep, it strengthens you, right? So there's some evidence there for the restorative theory. Running out of time here, so I'll just talk real quick about the last two, and we'll have a little bit of stuff left to finish up in this chapter next time. The circadian rhythm theory is based on evolutionary psychology. So it says that maybe we evolved the behavior of sleeping at night as a protective mechanism to avoid the dangers of nocturnal life. It's more dangerous at night for people. We don't have good vision at night. We don't echolocate. We're not bats. We don't have eyes like cats where we see really well in the dark like other animals do. Nighttime is dangerous for humans. As far as visual acuity goes and seeing in the dark, humans have mediocre vision. Our vision is mediocre. There are animals that we definitely see better than, but there are a hell of a lot of animals that see better than us in the dark. Cats and dogs included, by the way. So our night vision in particular isn't great. And because of that, nighttime is dangerous for Homo sapiens, human beings. So if we know what's good for us, we seek shelter at nighttime, right? So it would make sense to do our sleeping during that time, right? So the theory here is that we evolved sleeping when it's dark as a protective mechanism to avoid the dangers of nighttime. That's one possible theory. The consolidation theory comes from memory research and learning research. And there's a lot of evidence to suggest that learning and memory functions better when you've had better sleep, right? So these are some of the leading theories on why we need sleep. And again, if you get enough sleep deprivation, theoretically it can kill a person. We've done it with rats and mice. I'm not aware of any, because it would be unethical, right? Maybe the Nazis did it and I don't know about it, but I don't know of any laboratory studies that have been done that have pushed a human being to death through sleep deprivation. But it's been done plenty of times to rodents. So we know that sleep deprivation can theoretically kill a person, because if it can kill a rat or a rabbit, it can kill a person, right? We just don't know at what point we get to that point. But theoretically, the limit does exist, which hasn't been identified to my knowledge. So that's all I have for you guys today. We're out of time. There's just a little bit of stuff here on sleep deprivation. I've got some stuff on sleep disorders I want you guys to read about on your own. I want to finish this chapter relatively quickly next time. So I'm not going to talk about sleep anymore next time. So read about sleep pathologies on your own, many of which are listed on this slide. It's relatively straightforward material. We're going to finish this chapter next time by talking about what I consider and what you guys will probably consider the most interesting part of the chapter, which are your altered states of consciousness other than sleep, right? So referring to hypnosis, meditative states, flow states, and of course, we can't talk about altered states of consciousness without talking about psychedelic drugs. Weed included, by the way. A lot of people don't realize this, but weed, or cannabis as it's properly referred to, is categorized as a mild hallucinogen, just so you know. So we'll talk about drugs, man. We'll talk about that a little bit next time, and we should have plenty of time to at least start the next chapter, which will be chapter 5 on sensation and perception. We're skipping chapter 4 in this course. Sol, you have a question?
Do you know what our essay assignment 2 is on?
Assignment 2, I'd be happy to talk about it right now. Anybody who needs to sign out can go ahead and do so, but I will go ahead and talk about essay assignment 2 and also mention that I acknowledge that I haven't gotten the first round graded yet, so that's something that I'm behind on, and I'm gonna go ahead and blame that on Mustang Sally. But I know my excuse for that is running out. I'm getting to the point here where I need to have those graded, so I apologize for still being behind on that. And I do aim to have those graded here this week. I am out of excuses, so I need to get on that. But let's take a look at the second essay assignment here. I can get that pulled up. Having a little bit of a Zoom's not cooperating with me right now, guys. I apologize. There we go. Okay, so for essay assignment 2, there's a checklist for one thing that you guys will want to take a look at before you submit the essay. Essay assignment 2 is what is referred to as the GLOW assignment by the faculty. All the faculty members who teach this course give this writing assignment. So the first and the third writing assignments will vary depending on which instructor you take in this class. But when you take general psychology for essay assignment 2, all students who take this class, regardless of instructor, get this assignment for essay assignment 2, because it's what we call the common writing assignment, or the GLOW assignment. I won't concern you guys with that any further, but it's our common writing assignment that we all use through all the sections. So it involves taking a personality test called the VIA Character Survey, and the link to that is here. Let me make sure that link is still up to date. So it'll take you to this website, the VIA Character Strengths Survey. Are you guys seeing this okay through the share screen? Okay. And you'll get registered to take the survey. It takes about half an hour to 45 minutes. I think it's about a 150 item personality test. It's a real personality test. It's not one of these, BS Facebook personality tests where you find out if you're a Gryffindor or a Slytherin or something. By the way, I'm a Ravenclaw, in case you're wondering. But in any case, it's a real personality test that's been developed by psychologists. Martin Seligman in particular was the psychologist who developed it. But it's a personality test that identifies your character strengths. So you're going to take that test, you'll get your results, and you're going to write an essay about your results. So I want to know all about your top 3 results. I want to know what your top 3 results were. First person is fine for this. So if you write about I, me, that's totally fine. You don't have to write this in third person. Although I do encourage third person perspective for academic papers, probably more for your third paper. It will probably be a third person perspective paper. You're writing about yourself for this paper. So first person is fine. You can write it in third person if you want, but it's weird. Students do it sometimes, but it's weird. So I'm totally okay with that. But you're going to write about I would recommend maybe a paragraph for each trait, your 3 body paragraphs. You can break it down in different ways. Uh, you know, basic essay structure, APA format. I want one scholarly reference. So that can either be your textbook or something scholarly that you find through a journal. Chapter 13 would make sense because that's the chapter on personality, or chapter 4, which we're not covering, which you can read on your own, which is the chapter on nature and nurture, human growth and development. But I want you to write about your results, and I want you to give me your best theories on why you are this way, right? Why are these 3 traits your top 3 character traits, right? How did you end up with these strengths? Was it through genetics? Was it through learning, through your environment? What combination of nature and nurture, conspired to make you the person you are, right? So, obviously this is going to be your opinions about yourself, right? So here's your chance to write about you, and why you are the way you are. Or as if anybody watches the show The Office, as what's his name asked Dwight, why are you the way that you are, right? What's his name? What's the main dude? Is it Mike? Is that his name? I can't remember but he asked Dwight, why are you the way that you are, right? Well, that's the topic of this essay, basically. And we want good APA format. Try to write it with good grammar, etc. But you're writing about you, and it's your chance to tell me all about yourself. Yes, Sol?
So a couple questions. The checklist template, we just copy and paste it onto another page after our essay, after the works cited page, and submit that with
that's totally fine. Yeah.
Is that okay?
That's okay. And honestly, the template file is really just for your benefit to make sure that you've dotted all your I's and crossed all your T's. I do want to see it. I'd like for you to do the template file. Yeah, do go ahead and do the template file. But I mean, the main thing that I'm concerned about, more so than that you give me the template file filled out, is that you actually do the things that are listed on it.
Oh, that you answer those questions in your essay, basically.
Right. Yeah. So, if you've done the things that are on that template file, I honestly, I'm not too emotionally attached to you actually filling it out and giving it.
Because it says you must submit this with your essay. So I just
want that another faculty member insisted on having that on the assignment, and technically, yes, that is what the department wants. So do turn in the template file, because I'm going to shut my mouth. I'm not going to say anything more. But
what is the scholarly reference? What do you mean by that?
So the textbook or a journal article. So
it has to be a reference from the textbook. It could be a reference from
right. Yeah. So what I mean is, we're talking about your personality in this essay, right? So, and we're talking about nature and nurture. So the 2 chapters that really talk about those chapters a lot, the 2 chapters that talk about those ideas the most in the textbook are chapters 4, which we're skipping, and chapters 13 on personality, which I think we're also skipping, interestingly enough. But I don't think we're covering the personality chapter, if I'm remembering correctly. But you can still read those chapters on your own and reference them, right? So, just reference some idea in the textbook that's relevant to personality or nature and nurture, and just throw in an in-text citation that says Grayson et al., whatever the year of the textbook is it 2016? I can't remember now. Whatever the current edition, whatever edition you're using, actually, it'll affect what year it is. If you're using the 3rd edition, it'll probably say 2019 or 20, I think. But just cite the textbook, and maybe the page number you found the idea on as an in-text citation, and then throw the textbook onto your reference page. And I'm happy with that.
What do you, wait, you mean cite it in the paper or cite it in the reference page?
Both. Yeah. So the way APA format works is that anything that shows up on your reference page is supposed to show up in your text as a citation too. Now, if you didn't do that in your first essay, don't freak out. I'm not going to be, I'm not too draconian on my grading of APA format. I pretty much reward effort on that, and I only take off points lightly for APA format. The only time that I'll really take off for APA formatting in a significant way is if you don't try, right? If you give me a paper that you've not even attempted to put into APA format, then I'm going to probably dock some significant points for formatting. But yeah, technically in APA format, anything that shows up on your reference page shows up in the text. So I'll show you the example of this. And I do have to go in a second because I have to make it across the Garcon Point Bridge, and I have to make it to Gulf Breeze by 11 o'clock. And I hear the traffic is bad because the 3 Mile Bridge is out.
Yeah.
I can do like 5 more minutes here. I do want to show you guys. So on the template file, you'll see that every reference that shows up on the reference page also shows up in the text as a citation. That's the way APA format works. So, and by the way, the template file is for the second essay.
Wait, so that's not the same template as the first one? We're not using the same template as the first one?
Oh no, it's the same template file. And in fact, I misspoke. The old template file that we used to use was I misspoke. The sample papers that I provide are from the second assignment, is what I was thinking about.
Okay.
The template file is general, but the sample papers, the sample A and C papers that I provided are second essay examples, is what I was trying to say. But the template file applies to all 3 essay assignments. But what I was trying to get at here was that anything that you see on the reference page, and I'm not sure why this reference page is sideways. That's weird. I didn't notice that was happening.
It wasn't before.
That's disconcerting. But anything that shows up on the reference page should show up in the text. So for example, here we see Zimbardo 2008, The Lucifer Effect, which is a great book, by the way. But we should see that somewhere in the text. Let's see.
Is it the full site, or is it just like you said, like it was just the Gray's Ethel 2016 and a page number in the essay, and then in the cited page at the bottom after the essay, it's the whole site, or do you want them to be identical in the essay and on the cited page?
Oh, the citation won't look like the reference.
That's
so,
what I'm, okay.
Right. So for example, here's the Zimbardo citation. Right. Here's what it looks like. It's got his last name, comma, the year the book came out, and the page number in parentheses. So if you were using your textbook, it would say Grayson et al. 2020, page whatever. That's what it would look like.
And then on the works cited, it'd be a full site, right?
Yeah, and then it would be the actual reference.
Okay, cool.
So when I say reference, when I say a reference, I'm referring to what's on the reference page, or what you might call the works cited page, same thing. But when I refer to what's written on the reference page, I call that the reference. When I refer to what's in the text, that's called the citation.
And we at least have to have one citation,
One
but
citation and one reference.
Oh, really? But we can have more references than citations, or does it have to even out?
They have to line up. So
Okay.
anything that's mentioned in your text as a citation has to show up on your reference page.
Oh, I didn't know that. Okay, so we can do the one site and one reference, and we'll be okay with that? Okay.
Yeah. And anything that shows up on your reference page has to show up as a citation, right? So if you have one, if it shows up in one place, it has to show up in the other.
Right.
That's like algebra. What you do to one side, you have to do the other.
Yeah, on my first essay, it was just, I had like 3-4 references, but I didn't include it in my essay.
You didn't
So,
provide citations, but you gave the references.
yes, yeah.
And that's, I'm going to see a lot of that on the first round of essays. And I'm probably not going to be too draconian about that. You might end up with losing a point over it.
Now, you want them in parentheses, correct? The sites?
Correct.
Okay,
Citations. Yeah.
all right.
That's fine. Yeah.
Yeah, I don't really understand why we're never really taught APA format. It's only ever MLA. So when I started getting classes that are like, hey, write this paper in APA format, and I'm like, what the hell are you talking about?
Yeah. And chances are you'll never see APA format ever again if you're not a psychology major. Yeah, chances are. So you probably will never have to deal with it again unless you go into my discipline or a science discipline. A lot of times scientists publish their research manuscript, like even biologists and physicists, for whatever reason.
My biology class, we were doing APA too.
Yeah, biologists, for example, for whatever reason, like to write their papers in APA format. But historians don't, right? So, it varies by discipline. Historians have their own style. English majors have their own style. That's MLA. There's another one for journalism. I think it's called the Chicago style, if I'm not mistaken.
Yeah.
I'm not too familiar with Chicago. I've never even used it. There are a lot of formats out there. Okay, so I need to give myself enough time to get out to Gulf Breeze. I have not made this drive yet since Sally. I have no idea what this traffic's going to look like. Have you guys done it yet?
It should be good now. It should be a little better than it was because the bridge is still.
I'm going from Ferry Pass. I'm leaving from Ferry Pass. I live on Olive Road. So my plan is to take Davis down to I-10 and then take Avalon. I don't think it'll be too bad, but I got to give myself, maybe I'll find out today that I'm giving myself more time than I need, but that's a good problem to have, I guess.
Yeah, well, good luck.
Yeah, thank you guys. And I'll see you guys on Wednesday. And it's going to be a good week. I'll see you guys later.
Bye.